we are going to look at half angles one more time. Okay, the first thing we have to know is where the full angle is and where the half angle is. Okay, so this says alpha is 120 degrees. So where is half alpha? Half of 120 would be 60 degrees. Okay, and this is the half. I highly recommend drawing where the angle is in which quadrant. Now it's time for the full angle alpha. The full angle would be 120 degrees, and here's the full. Saying the sine and cosine of the full angle is usually pretty easy. The sine of half alpha. So which angle are we going to look at? We're going to look at the half picture. The sine of half, since it's in quadrant 1, would be positive. The sine of a cosine angle in quadrant 1 would be positive. And the tangent would also be positive. Okay, and you look at the half to figure that out. So you always look at the half to figure out the plus or minus sign. The full angle helps us in the calculation. So that's how you do angles that you know from the unit circle. If the angle is known, you use the unit circles to calculate. Now, what if they just say with words something a little more abstract? So if alpha is in quadrant 3, okay, where would the half be? So full alpha is in quadrant 3. This is angle alpha. If I take any angles in quadrant 3 and chop them in half, what's half of, let's see, a number here could be like 200. Half of 200 would be like 100. Half alpha would be right here, 100 degrees. So this is where the half would be. Oh, I shouldn't say that. I should just say alpha over 2. I was just making up 100 for an example. Okay, so if you start in quadrants 1 or 2, and I chop you in half, you end up in quadrant 1. If you start in 3 or 4 and I chop you in half, you end up in quadrant 2. Okay, the sine of half alpha. So let's look at the half. He's in quadrant 2. The sine is positive, the cosine is negative, and the tangent would be negative. Okay, if the angle is unknown, you draw the triangle, use the Pythagorean theorem. So you'll probably know stuff about full angle alpha. You have to put the negatives out in the right spot, and then you use the formulas. Hey, speaking of those formulas, let's make sure everybody has those uglies down. Okay, remember we called these the uglies. That is not an official math word. Okay. The sine and cosine are really ugly. They both have plus minus signs out in front, and you have to pick the correct sign, like we just talked about here by looking at where it is. They both have these huge radicals. Inside the radicals there's fractions. In the denominators of both of them, they both have a 2. The numerators look very similar. They both have 1 and cosine. 1 and cosine. If it's a sine calculation, then it's going to change. He's going to get a minus. If it's a cosine calculation, then you're going to put a plus. Now if this says x divided by 2, that's the half, right here you're going to say cosine of full angle x. Half angle x, this is going to be a full angle x. Make sure your radical is really tall and covers up that 2. It's in the radical. There's a couple tangent formulas, but the one that I highly recommend is the one that's just a fraction without a radical sign. The numerator is 1 minus cosine of x. Tangent's like sine over cosine. And the bottom is sine of full x. Remember, this is the half angle. And I don't know that one, I can't calculate it, but this is the full angle, and there's usually a picture or a unit circle to help you figure that out. Okay, we're going to do a couple calculations here. The first one says tangent of 13 pi over 8. Now 13 pi over 8, I don't know that from the unit circle. Okay, that must be a half. So I'm going to draw some pictures. First of all, where's the half? And where is the full? Let's see, 13 pi out of 8. I know 8 out of 8 is right there. This is 4 out of 8, 8 out of 8, 12 out of 8, 13 pi over 8 must be right here. Okay, this is 13 pi over 8. Wow, that's the half. Okay, so where's the full? What is 13 pi over 8 times 2? Cancel, cancel. 13 pi over 4. Oh, I know the pi over 4s. I just have to figure out where that is. 4 out of 4, 8 out of 4, 12, 13. Here's the full. The full angle is in quadrant 3. Okay. To figure out the tangent, I'm going to use that easy formula. 1 minus cosine over sine. Now, some of you are kind of doing some weird things where you put the answer here. When you say cosine of, you need to put an angle. Should I put this angle? No, I don't know that angle. You put the full angle right here. So you have to say 13 pi over 4. Sine of 13 pi over 4. And that should be one you know from the unit circle. Equals. Okay, now it's time to evaluate. What is the cosine of 13 pi over 4? That angle is in quadrant 3, so it's going to be negative radical 2 over 2. What's sine of 13 pi over 4? Negative radical 2 over 2. Wow, there's a lot of 2's here. A negative minus negative, I'm going to cancel those out. I'm going to write this as 2 over 2. And then all these denominators can go away, and we're left with 2 plus radical 2 over negative 2. We're going to have to rationalize this. So let's multiply with parentheses top and bottom by, we could either do just a regular radical 2 or we could distribute the negative. Maybe I'll do a negative radical 2 so I don't have to worry about negatives later. Either you do it now or you do it later. So the denominator is positive 2. And the numerator, distribute is negative 2 radical 2 minus 2. So who gets divided by 2? The first term or the second one? And the answer is both. So it's going to be negative radical 2 minus 1. There you go. All right, let's do a cosine problem. Cosine of 7 pi over 12. Okay, let's figure out. That's the half angle. I don't know that one from the unit circle. Where is 7 out of 12? 12 out of 12 is right here. 6 out of 12 is right here. So this must be 7 out of 12. 7 out of 12. That's the half. Now, where is the full angle? Let's take 7 pi over 12, and let's times it by 2. Cancel, cancel. That's going to make 7 pi over 6. 7 pi over 6 is right here. 7 pi over 6. That full angle should be something you know from the unit circle. Okay, we're doing a cosine problem. So I need to decide if I'm going to pick the plus or the minus in front of the big radical. And how do I know what to pick? I use the half angle. So since we're in quadrant 2 and we're doing a cosine calculation, quadrant 2, I'm going to pick the minus sign, the negative. Okay, now let's do some nice work in here. Some of you are missing the first couple setup lines, and I'd like you to write this out. 1 plus cosine of, now put the full angle here, write 7 pi over 6 all over 2. Okay, if you've done enough of these, you realize the same thing happens every time. So we're going to have 1 plus cosine of 7 pi over 6, that's in quadrant 3. The cosine there is negative radical 3 over 2. Okay, how should I write that 1? I'll write the 1 as 2 over 2. How should I write that 2? Let's write that as 4 over 2. Why am I making so many 2's? All the denominators cancel. So we have negative square root of 2 minus radical 3, and that's over 4. Can a 4 come out of a radical? Yes, so draw a nice long divide bar. Out of the radical, it's gonna be a 2. Okay, so this is how you do half-angle problems with the unit circle. Sometimes they give you information and we're going to draw a triangle and use different values. Okay, so let's go ahead and try this here. We have to find some half angles. It says x, let's see, cosine is negative, and this says cosecant. If you don't like cosecant, maybe we can write this as sine of x. Do you want to flip this? Some people like to see opposite over hypotenuse a little bit better. Okay, I can rationalize this because this looked like it got rationalized. So if you do it again, if you rationalize or rationalize, it actually simplifies. We have 3 radical 3 over 2 times 3. Cancel, cancel. So we have radical 3 over 2. All right, let's go ahead and draw this picture. The sine is positive, so I'm not going to draw it down here. And the cosine is negative, so where should I draw it? Let's put it in quadrant 2. So here is full angle x. This is a full angle x, full angle in quadrant 2. All right, let's put some numbers here. Sine is opposite, radical 3 over hypotenuse 2, and it looks like I'm going to have to do Pythagorean theorem. A squared plus b squared equals c squared. Do I need parentheses here? Am I going to lose a point? Well, since the entire radical is getting squared, you don't need them. If there was a number, then you'd have to use parentheses, but this is fine. A squared is 4 minus 3, so a is 1. Okay, so how long is this leg right here? Careful, it's going left. Yes, negative 1, just like it said, cosine is negative. Okay, I've got a full angle x picture, but now I also want to draw a half angle. If I take something in quadrant 2 and I cut it in half, where is half of x going to be? In quadrant 1, this is x divided by 2. Here's the half. Okay, and I need to know where the half is so I can pick the correct sign. All right, let's do our sine calculation first. Sine of half angle x. So let's pick the plus or minus. Tell me where it is. And let's pick the positive sign. Okay, so I'll pick the positive sign. Big radical. 1 minus cosine. If I'm doing a half angle calculation, I'll put a full angle right there over 2. Now, how do I know what the cosine of a full angle x is? You look at your picture. We've got 1 minus, what's cosine? Negative 1/2. So negative, negative cancel all over 2. All right, now it's time to make some common denominators. I'm going to write 1 as 2 over 2. I'll write 2 as 4 over 2. So in the numerator we have 2 plus 1, 3 over 4. Now you can't leave it like this because the denominator has a radical. So let's take the radical of top and bottom. The square root of 3 is the numerator, and radical 4 is a 2. Okay, so the sine is radical 3 over 2. That worked out real nice. All right, let's do a cosine calculation. Looking at the picture, should I pick plus or minus for cosine? It's in quadrant 1. I'll pick the positive sign. And cosine formula is 1 plus cosine of the full angle x over 2. Similar numbers, just a slight difference, right? We have 1 plus the cosine of full angle x is -1/2 all over 2. Let's make common denominators of 2, 2, 4, and 2. Okay, why do we make all those 2's? To cancel all the denominators out. So in the numerator I've got 2 minus 1, so I've got radical 1 over 2. Radical 1/2, let's take the square root of 1 and get 1. Let's take the square root of 2 and get 2. But I'm not going to say the answer like that. I'll say radical 2 over 2. Now, I know that we could take our two answers and check, but I want to do the third formula, and then I'll do the dividing of the two just to see if I'm right. If I get the same answer here as I do with those, I know that everything is correct. Okay, it's a way to catch a mistake. Of the three formulas, I like the one that goes 1 minus cosine of full x over sine of the full angle x. So we've kind of done cosine a lot. 1 minus, what's the cosine of x? -1/2. Okay, cancel, cancel. And sine of x, here's the first time we do sine. Sine is radical 3 over 2. Radical 3 over 2. Let's write that 1 as 2 over 2. That's a lot of 2's. So the numerator is 3 over radical 3, which we will rationalize and get 3 radical 3 over 3. So I believe the correct answer is radical 3. So what was that other way of doing a fast, easy problem? To do tangent of half x. Tangent of half x, you could take sine of the half over cosine of the half, as long as they're half, half, half. So what did we get for sine's half angle? We got radical 3 over 2, and our cosine answer was radical 2 over 2. And this is not quite working, is it? So that means there is a mistake somewhere. I really wish I had some smart students that could look this over and figure out where did they go wrong, because sine over cosine is supposed to make the same answer. If this happens on a test, you have to be able to look through your steps and figure out where you went wrong. Okay? Please try to do that, and let me know if you're able to find it tomorrow in class. And just to make sure you get enough practice, here are some problems for you to try on page 34. Good luck, all you smart students.